Welcome everyone. This is the first lesson recording for IM2, October 19th, 2020. So we first began by going over the homework answers. So if you want to do this, then you do need to be present during the class. What are we doing today? We are going to continue with the application of similarity. And we're going to be discussing congruence versus similarity, compare and contrast. So we're going to bring what we know about congruence and what we know about similarity and make some connections there. And then finally, we're going to discuss the Unit 3-4 tests. All right, let's begin with this. Do you recognize what this picture is? Okay, well, if you said it's the Big Ben clock tower in London, you were correct. I have not been, but I would love to go visit one of these days. So Latoya was trying to take a picture of her family in front of the Big Ben clock tower in London. However, after she snapped the photo, she realized that the top of her father's head exactly blocked the top of clock tower. While disappointed with the picture, Latoya thought she might be able to estimate the height of the tower using her similarity knowledge. So she's going to do that. You need to sketch a diagram of the situation, then identify any triangle that must be similar, and you must state how you know that they are similar, and then use your knowledge of similarity to find the height of Big Ben. And you should be taking notes, please. Okay, so here we go. Okay, height of Big Ben. This is the picture of the situation. This is the height that we are wanting to know. That's the question mark feet. This is how tall Latoya's dad was. And this is how high the camera was angled. Okay, it wasn't at ground. It was 2 feet above the ground. We know that distance from the camera to Latoya to her father was 12 feet. And we know that the distance from the father to the building was 930 feet. Okay, so how do we do this? Well, I don't see any triangles here, right? But but is there a way of making some triangles? Or what if we drew an auxiliary line, that means extra line that is horizontal, so it's going to be parallel to the ground level. Okay, so if I do this, what do we have now? We have the angles, one pair of angles that are similar, and we know that this red triangle and the purple triangle, they share the same angle here. So we have another angle here. So if we bring the red triangle here, and if I bring the purple triangle, it's always easier to not make any mistakes if you draw the two separate triangles. Okay, so then from here I know some of the measurements. Okay, so I know that this is 12 feet because the distance from the camera to her father was 12 feet. So this has to be the same. What else do we know? We know that his total height is 6 feet, but we know that this height is 2, so this triangle, the height of this triangle is 4 feet. Okay, we know that this is not 930 feet, but it's 12 plus 930 feet. And what about the height of the tower? Well, we don't know that. Okay, but we do have, what have we established? We have a pair of angles that are congruent, and another pair of angles that are congruent, this angle and this angle. So by AA similarity, the two triangles are similar. That means we can set up the ratio, and we can set that to be equal to each other, or the proportion equation. Okay, so question mark feet corresponds to 4. So question mark over 4 is going to be exactly the same as 12 plus 930 divided by, which one does side this corresponds to? 12. Okay, and then if I simplify this, the question mark becomes 314. So is that the height of the tower? Not quite. We still have to add that 2 feet here. Okay, At that 2 feet, that comes out to be the tower is 316 feet high. Okay, another application problem. Katerina's boat. Katerina's boat has left without her. She's standing atop a cliff that is 35 feet above the water in a lake. She stands 10 feet from the edge of the cliff, so the distance from her foot to the edge of the cliff is 10 feet. She can visually align the top of her cliff with the water at the back of her boat. Her eye level is 5.5 feet above the ground. So from her eye level to where she's standing, that height is 5.5 feet. So just picture what's happening, okay? So she's looking down and she's drawing a triangle right directly to the edge of the cliff, and that goes to the end of the tip of the boat. Okay, so see if you can imagine a triangle or the situation. Okay, here it is. So there is Katerina standing. When she looks down and lines up the tip of the cliff, she can see the tip of the cliff and the back of the boat perfectly lined up. Okay, and the distance from the cliff edge to where she's standing is 10 feet. She knows that the cliff is 35 feet. We're trying to figure out how far is she, or how far is the boat from the shore. Okay, so now can you draw your can you set up the two? Can you draw two triangles? And then can you write the equations? Make sure you're using two ratios of corresponding sides, and then solve it. Okay, so the two triangles we have are the red triangle and the blue triangle. Now, are they similar? Well, we have one pair of congruent angles. We need at least another pair of congruent angles or proportional sides. Do we have another pair of angles? Yes, because we have this angle, because that angle is making with the horizontal ground level, and this is also against the horizontal level. So we have angle and another pair of angles. So by angle similarity, the two triangles are similar. Okay, if that is the case, then we can set up the two equations, or an equation that that sets the two ratios to be the same. So I know that 35 over 5.5 is going to be same as D over 10. Again, always start by setting up the equation. Try not to do the scale factor, because scale factors are great if the numbers are evenly divisible and we're dealing with a whole number. But when you're dealing with some odd numbers, you're going to get that confused. Okay, so it's going to be far more consistent if you use this proportion equation. So then from here, I can cross multiply. And so I'm going to cross multiply 35 with 10 and 5.5 with D. So that's going to be 35 times 10 is going to be equal to 5.5 times D. Okay, and I'm going to use parentheses just so that I do not get the decimal place mixed up with multiplication. So that means this is 350 is equal to 5.5D. So divide both sides by 5.5. And using the calculator, I get the distance is 63.6 feet. Okay, so I know that the boat has traveled 63.6 feet. Okay, it's your opportunity to try this application problem on your own. Make sure for each problem that you are sketching the diagram and labeling it, explain where the triangles and why they are similar. Okay, so you need to first establish similarity before you can just set up the proportion equation then to solve. If you're done early, you can do challenge problem 3 to 5. So and the document would look like this. And you can get the link for this document from the lesson resources in Canvas. Okay, so please pause the video, open up the document, and try to solve the problem as much as possible. And I'm going to be showing you the answers in 3, 2, 1. Okay, here we go. All right, so the first problem, you need to first draw your two triangles. Okay, if you can visualize the two separate triangles on its own, that's fine, but generally it's going to be far easier to set up correct equation if you are separating the two triangles. Okay, so we have 60 meters here, 35 meters high for the height of the pole, and 170 meters from that point, and the height is here. And then so the equation, okay, so match up the parts. 60 matches with 170, so 60 divided by 170 is equal to 35 divided by h. 35 matches with h. So start with the proportion equation. Then you cross multiply. But before you cross multiply, at the very least, I can just divide both sides, top and bottom, by 10, so that I'm dealing with smaller number. Smaller numbers are far easier and you are less likely to make mistakes. That means 6h, 6 times h is going to be equal to 17 times 35. And so 6h is 595, divide both sides by 6, and you get h to be 99.2 meters. Number 2, again, you do the same thing with the triangles. Okay, but one thing that you might notice is that as far as the property of light, if you put a mirror here, the way the light reflects, they reflect at the same angle, or so what we call angle of incidence is always going to be same as angle of reflection. So this is always going to be the same. We also have another pair of congruent angles because we know that this man is standing vertically, as well as the building hopefully is vertical as well. So we have two pairs of corresponding angles that are congruent. That means by AA similarity, the two triangles are similar. Now again, set up the triangles and then match them up. 1.92 matches with x. So 1.92 over x is 0.4. 0.4 divided by 87.6. Probably the biggest thing is make sure that if the top triangle is the left small triangle, then make sure that both numbers are occurring at the top and the bottom parts, corresponding parts length are occurring at the bottom. If you have flipped this and said x over 1.92 is equal to 87.6 divided by 0.4, it will work out to be exactly the same because you're going to be cross multiplying, so it does not matter. So after cross multiplying, I get 0.4x is equal to 1.92 times 87.6. Again, notice the fact that I use parentheses because we're dealing with decimals, and it's really easy for us to think that decimal is a multiplication, and you are going to do the multiplication instead of treating it as a decimal point. Then we divide both sides by 0.4, and then finally get the x to be 420.5 meters. Okay, when you are dealing with application problem or any other problem for that matter, when you get your answer, you should always be checking to see, is my answer reasonable for this problem? Okay, for the second challenge problems, I am just going to show you the answers. See if you can figure it out. If you need some help, you can come see me. All right, please pause the video, look at my answers. We'll continue in the next lesson recording.